We are looking at the Guadalupe Nipomo Dunes, one of the largest coastal sand dune complexes in California. This magnificent landscape is truly one of nature's most impressive and beautiful creations. In this video, you will learn where these dunes came from, how they constantly change, and where they are going. On the North American continent, in our own United States, inland desert and coastal dune regions have formed mostly in the southwest interior region and in places along both coastlines. On the west coast, the state of California contains several large inland desert dune regions. But California is a state especially known for its many beach areas, and in these coastal areas one finds several coastal beach dune regions, with the Guadalupe Nipomo Dune Complex perhaps the most spectacular of all. Located along the central California coast at the southern end of San Luis Obispo County and the northern end of Santa Barbara County, this magnificent dune region stretches approximately 18 miles along the Pacific Ocean, from Point Sal in the south to Pismo Beach to the north. The Nipomo Dune Complex is an area covering over 10,000 acres and includes the Calendar, Guadalupe, and Muscle Rock Dune regions. Ownership and management of dunes land is held by private landowner, county, state, and federal agencies. The climate of the dunes complex is typical of California's Central Coast. Foggy mornings, followed by sunny afternoons. Winters are mild here, with occasional storms. A strong prevailing wind coming in from the northwest over the Pacific Ocean dries the wet beach sand, blowing it inland. This wind often blows for long periods of time, and often at speeds of 25 miles per hour, to help produce some spectacular dunes that constantly move and change right before our eyes. A variety of plants have adapted to this harsh dune environment. Many of them are native to the region and have survived over the years in the dune's severe climate. But how did all of this get here? Geologists tell us that our planet Earth had severe weather changes over millions of years, resulting in a series of extreme cold periods, or ice ages. During these times, large glaciers, or sheets of ice, formed from the freezing oceans and lowered their levels. Later, when our planet gradually warmed, the melting glaciers replenished the oceans and raised the water level, slowly flooding the lower areas and creating a new shoreline. During this period, other areas such as the Santa Lucia Mountains further inland received large amounts of rain. The streams running from these mountains carried large quantities of sediment onto flat floodplains along the coast where it was deposited. As the last ice age came to a close about 12,000 years ago, the waves of the rising ocean reduced the mountain sediments to sand, grinding the heavier sediment into granules. A southerly current along shore carried the sand from the northern end of San Luis Bay to the northwest-facing shoreline. The waves and current moved sand northward from south of the Santa Maria River. As the sand was deposited on the beach, the prevailing wind carried it inland. Geologists have determined that there were three major dune-building periods. Each of these dune-building periods was related to a corresponding rise in sea level. During the first period, the ocean waves worked on the lowest level of sediment, and gradually the resulting sand was moved inland by the wind. Each successive rise in sea level added to the sand accumulation. The third dune-building period continues today. The Santa Maria Valley, a tremendous agricultural area reaching toward the ocean, was created by the uplift of hills. This area contains the highest dunes in the dune complex. Jutting out to the Pacific at Point Sal and Muscle Rock, the extreme southern end of the Guadalupe Nipomo Dunes. The Santa Maria River, winding down from the Santa Lucia Mountains to the east, slowly carries sand sediment, which is deposited into the Pacific Ocean. Current sand dunes are now advancing over the remnants of the older dunes left behind when sea level was high enough. The earliest sheets of sand, blown in nearly 1 million years ago, lie under what is now the Nipomo Mesa. The Nipomo Mesa, which resulted from shifting of the ocean's shores over millions of years, includes several layers of very old sand, now covered with a variety of plants. This ancient dune sheet extends all the way from the current dunes just east of Highway 101, as seen in this aerial view. But what about the ever-forming dunes along our beautiful beaches? Our beaches form due to a variety of factors. The prevailing wind and wave direction affects the California coastline. Here one can see the similar shapes of the large bay formations, including San Luis Bay. The shape of these bays, with the curling northern end and flattened southern end, comes from thousands of years of direct effects of winds and tide. Because of the shape of San Luis Bay, waves tend to sweep sand northward from the southern end of the bay and southward from the northern end of the bay, sweeping sand toward the central portion. In the center of the bay, the sand starts to accumulate in wide beaches. Here in these mountains, 30 miles from the beach, the weathering and erosion of rocks releases rock and mineral grains to the creek. They are washed off the rocks by the rain and carried down the creek. Once at the river mouth, the sand grains are now at the mercy of the waves and deposited offshore as sandbars, ready to be carried northward by ocean currents. These waves are often generated by storms hundreds of thousands of miles away. Crashing waves and high tides pull sand off the shore during the stormy winter months. Summertime wave action deposits sand back onto the shoreline from the sandbars and builds up the beach areas. The waves approach the coast from the west in the winter and from the southwest in the summer. The direction of the wave compared to the direction of the coastline determines the fate of the sand grain. If you watch waves breaking on a beach, you can sometimes see them break at one end of the beach first. When the waves run up the beach face at an angle, sand grains are carried along the beach. When the water runs down again, the transport of the sand grains along the shore continues. During this long process, these grains of sand have been sandblasted and are very smooth and very round. The broad beaches dry out at low tide, and the wind carries the sand into the foredunes. Dune vegetation has adapted to the harsh environment of the foredunes and starts the process of dune growth by trapping sand in its root system. Dune formation begins when wind blows dry sand landward from the beach. Drifts accumulate around objects, such as plants and logs, that interrupt the wind flow. With steady winds, the sand drift acts as a barrier to moving sand, and the drift gradually grows into a sizable mound. Until a dune is completely stabilized by plant cover, sand may be borne away by winds. Sometimes the sand gets no further than the foredunes, which build to great height. These foredunes are forming today and are the transition zone between the open beach and the dune scrub community. In the dunes, there are blowouts through the foredunes, as the wind seeks the low spots, concentrates in those spots, and keeps them clear. The alternation of dunes and blowouts gives the foredunes an interesting appearance, with a series of ridges and swales paralleling the wind. Further inland are another, still active set of dunes from an earlier time. These dunes are referred to as mid-dunes. In these dunes, the sand runs up the gentle windward slope and slides down the steep leeward side. Gradually, the lee slope steepens into what is referred as the angle of repose, approximately 34 degrees, and as the wind can no longer flow smoothly over the dune crest, A wind shadow is created and the dune has now formed a slip face. Here, the coarser, heavier grains of sand tumble over the edge, while finer grains are blown over, continuing the process. Ripples in the sand are due to this continuing process as well. During periods of high winds, swirling blasts of air move the sand in many directions at a time, increasing the occurrences of these small sand avalanches, and often displacing enough loose sand on top to reveal these examples of sculpted wet-packed sand from below, caused by earlier heavy rains. One begins to appreciate the incredible beauty associated with these ever-changing drifts, and can truly recognize geology at work. Once the sand moves inland, the dunes stabilize. Plants may increase in number and can eventually completely cover a dune. When there is no vegetation and lots of wind to move the sand, parabolic and blowout dunes can form. An older set of dunes lies even further inland. This ancient dune area may be as old as 500,000 years. Although reactivated in some places, this back dune region has large areas of stabilized and vegetated dunes. Plants and grasses can begin to grow here, and gradually over many years, shrubs will take root. Flying directly over the dunes, one can see in some areas a very abrupt, almost startling contrast between these towering mounds of sand and the adjacent farmland. This farmland receives abundant water from wells that need not be very deep, as they draw their water from a high water table. These dunes are separated from the most modern dunes by a narrow valley, where groundwater is close to the surface and willow trees grow. Scattered throughout the dunes, one can see evidence of this high water table in several small, freshwater, landlocked lakes. The largest of these lakes is Oso Flaco, a sensitive freshwater marsh. Oso Flaco Lake provides visitors with access to the surrounding dunes, with this walkway stretching across the lake, winding along the creek, and ending at the beach. Oso Flaco Lake outlets its sometimes high water table level directly into the ocean. What have we learned about our own Guadalupe Nipomo Dune Complex? We've learned that it was formed and reformed from great changes and upheavals that have taken place over millions of years. That the Santa Maria River delivers a steady flow of sand to the Pacific Ocean from slowly eroding rocks far upstream. That the constant cycle of winter storms and summer waves, combined with offshore currents, bring this sand ashore to cover our great beaches. That the steady prevailing winds blowing in from the northwest dry out and push these tiny grains inland until they grow into hummocks, and then larger dunes, often shifting and moving inland. That subterranean groundwater helps keep small marshes, ponds, and lakes active at the surface. And that this vast dune complex is part of a much larger system, a magnificent, ever-changing area of sea and sand, ever-present, yet always on the move, dunes that provide a complex beauty that interplays with light and shadow, with subtle textures, that build with powerful grace to form the lasting presence of a true geological wonder, the Guadalupe Nipomo Dunes.